So hello guys, I'm Sridhar. So in this video, I'm going to explain about my code for my coursework to robo communication. So let's jump into it. So this code over here, what you see, it is the code for my coordinator XBee code. So over here, I use my STM32 F411 is my microcontroller and which is being communicated with by XBee coordinator. Okay, so in this code, I have used two library, embed.h library and string library. So as you see, I have declared my analog pin, which is my for controlling for getting the values from the potentiometer. I have connected to A0 pin out, and I also have been using two serial ports. One is for communicating via terminal, and another serial is for communicating the XBee itself. And there is also a digital pin. This is just for debugging. I have been using a button to check whether I'm able to transmit a signal or not. So 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 this is how the code works. It gets the value from the potentiometer and it sends the value to the create message, where the create message function is creating a messaging frame, and that messaging frame is sent to ZigBee, and the coordinator ZigBee transmit the messaging frame to the required router ZigBee. So the router ZigBee receives the message and extracts the data from the messaging frame. And it has a delay of 500 milliseconds for each and every messages to transmit through the coordinator. So when I click on the message create message function, you can see the clear the structure of the message is required. So it has a starting bit which starts from hexadecimal 7673, and it also has a message length. And over here I'm also declaring my router ZigBee's address, MAC address. And so over here in this function, it is also calculating the checksum, and um, it is being added to the messaging framework. So the messaging frame does sends a valid data through ZigBee to ZigBee, and these are the um, values indexing indexes for the messages for the messaging framework to be created. As you see, it starts with the starting bit and so on. It has a destination address and it also has a payload address at the end. So after it is being transmitted to the ZigBee, the message is also printed in the serial monitor, so the user can see what is the message frame it is being telecast to ZigBee, coordinated ZigBee to the router ZigBee, and what is the payload size. So payload size is represented in hexadecimal. Let's see the code behind the router ZigBee and the router STM. So in this I have used, this is the code for my router ZigBee, and over here I am using Nucleo F401 F401, and it is being connected to a servo, and the servo operates by a pulse width modulation. So I have declared pulse width modulation out for the servo from the pinout of T6. and it is also using two serial ports. One is for PC to communicate via serial terminal, and other serial port is used to communicate with the ZigBee itself. So let's right now go to the main workflow of the router's code. Initially, the router code, it it sets a memory value, and it sets the servo periodic response of servo. It is being set initially, and after that read it tries to read from the ZigBee serial port. Is there any serial communication is happening? Once there is a data coming through serial port of the ZigBee, it tries to check whether the starting frame of the messaging or the messaging framework data contains 07E. So if the message contains 07E, it tries to read the data from the starting bit. So once initially I had a problem of getting the data, but without knowing its starting bit, it the ZigBee used to get random data and it will try to find random values. But once you able to identify the starting bit of your of the signal, then you can extract the required information easily. So it was a very important process in this. So you need to get the starting bit. So after getting the starting bit, you can able to easily find what is the payload bit you're looking for. So our 15th bit of the 17th byte frame had my uh, was having my payload value. So after getting to the exact bit which I wanted, I can extract the data of my payload angle I'm printing them in the serial monitor. So to control the servo, you don't need to play with the angles, but you need to map the values from the potentiometer, which is 0 to 255, to the pulse width, which is being mentioned in the above code, to the minimum pulse width to the maximum pulse width. This is the function which maps the payload integer into required pulse width and returns the pulse width to the servo. So the servo knows what is the pulse width it should move according to the given given potentiometer value. So, and this is the code flow of my router script. Let's see the demonstration of the model itself.
So this is in this project I'll be showing how I'm able to transmit the data from this XBee to this XBee. So in this is the coordinator and this is my router. So this right from the port uh, you can see over here you are able to see the angle and you're able to see the integers also over here. The integer, it shows the values between 0 to 255 and the angle I required is 0 to 180. So when I try to rotate my potentiometer, you can see I can slowly move my angles of my servo, and you can also see the increase in the value. So right now you can see the value is high 255 and the angle also it's 180, and you see the servo position over there, it is 180 degree, and you can see my potentiometer, it is at that full level. Right now I'll go to 0 and you can see it is the servo is being rotating slowly. And right now you can see my integer value is 17 and the angle is 15 degree, and right now you see for a certain time it went to 0 and it's 15 and the integer value is 22, and you can see my servo position, it is in the straight. So thank you.